Okay, so we'll be solving this question, sum of root to leaf binary numbers. So in this question, we've been given a tree with only values of 1 and zeros. So what has been given here? Let's analyze. 1 0 0. So root to leaf value 1 0 0 we have been given in here. 1 0 1 is given in here. 1 1 0 is given in here, and 1 1 1 is given in here. So we've converted these values to their that decimal equivalent, and we've added them. So this is what we have to do in this question, that we'll be given a tree with only zeros and ones. We have to find out the root to leaf path, and then we have to add these particular values. Okay, so let's brush up our binary operators a bit. So firstly, we know that if we have been given 1 and we say 1 left shift 1, this means 1 0. If I'll say 1 0 left shift 1, this gives me 1 0 0. Okay, so this is one concept. Another is that let's say I've been given 1 0 0, I'll say OR to 1, this will give me 1 0 1. Okay, so we'll be using these two particular binary operators. Also, in this particular tree, we won't have the base condition that if the root node is null, right? We will have we will have this particular statement that whether we have reached to this particular node, whether we have reached to a leaf node or not. Okay, so let's say the first condition that I'll say, root is equals to null, return 0. Now why have I written this particular condition? Let's say I've been given the tree null itself, right? The whole tree is null. Although I do not think that we will be reaching to this particular node. Then I'll say root dot left is equal null, and root dot right is equal null. That means we have a leaf node in here. We have a leaf node, right? But will we be requiring a current value as well? Yes, we will be requiring a current value, and because of which we have to create a helper method, right? So I'll pass a tree node, root, and a current value. Now why will be we requiring a current value? We will be requiring a current value to store this particular level, to store level by level data, right? So I'll show you how. Private int. Okay, so I'll say if my root is equals to null, this will return 0. Then I'll say if my root dot left is equals to null and root dot right is equals to null, that means this is a leaf. This is a leaf node. Now we need to add the value of the leaf node to current node, and we also have to keep a sum, a global sum. Okay, sum is equals to 0, and this sum will return, and we will return this sum at the end after calling this helper method. So we'll call it right now only root comma 0. So let this helper method return void, because let it return nothing, because we'll keep this particular sum as global value, so we do not need it to return anything. So I'll say sum plus equals to current left side left shift 1 or root dot value. So what I'm doing in here, whatever the value I have, let's say I have let's say previously I've got 1 0 with me. So let's say in this particular tree 1 0 1, let's say in 1 0 1 I've got this one, I've already have 1 0 with me. So what I'll be doing is left shift by 1, which gives me 1 0 0, and then I will be adding 1, which gives me 1 0 1. Or sorry, or I'll use OR operator. Okay, yeah, this will give me sum, and then I'll return. Then I'll have a traversal to the left side and to the right side, root dot right. Sorry, root dot left and root dot right, right? This will be left. Okay. Now what will be the current value that we are going to pass in here, right? When I'm at 1, I'll say okay, my current value is 1, right? But I already have a current. So what I'll be saying is int temp is equals to current this, and I'll say root dot value. So this is my value that I'm going to temporarily take. So since this value is equal to this value, I'll say temp in here and I'll pass temp values in here. Let's run it. Okay, it's working. So what we have done in here, firstly, we have set this condition of root is equals to null, simply return 0. Then I've kept a global sum and I've created a method called helper and passed in the current value as 0. So initially my current value is 0. Now, okay, so let's dry run it for this particular tree. Let's say my root is equals to null. Okay, so if my root is equals to null, will there anything happen here? Nothing. Okay, so this condition will not execute for the first time. Then what will my temporary be? So my current, initially my current was 0. 0 left shift 1 is 0, and or root dot value which is 1, so 1 gives me 1. So now my temporary will become 1. Is this is this condition fulfilled? No, this 1 is not a leaf node. So we'll go into this particular call and this particular call. So for this node, for this subtree and this subtree, I already have my current value to 1. So let's execute this tree again, right? So now this particular function has called again, but my current is 1. So when I came in here, will this that if condition execute? No, root is not equals to null. Then I'm at temporary. What will my temporary value be? So I'll say current is 1. So 1 mod this, sorry, 1 left shift 1 will give me 10, or operator 0 will give me 10 again. Sorry, 1 0 in binary. Okay, so this is here I'm getting 1 0 in binary. Is its left and right side null? No, right? That means it's not a leaf node. So I have 1 0 in my temporary variable, and I'll pass in temporary variable in here to my left side and my right side. Now is my left and my right side 0? No, right? Now what is my current value? Now my current value is 1 0. Now is my left and my right side 0? It's a null. Sorry, if my is my this particular node null? No, right? This node is not null. So I'll again go and create this temporary variable. I'll say current 1 0 left shift 1. This will give me 1 0 0, or 0. This gives me 1 0 0. So now I have 1 0 0 in my temporary variable. Now what I will be doing is, since this is the leaf node, its left side and right side are null. So I'll say sum is equals to temp. That means this particular value will get a value of 4, since 100 in decimal is 4. So sum will be equals to 4. Now this will return. As it did return, it will go to the call for this particular node. Now I already have current to 10, right? Is this particular node null? No. So it will say 10 left okay, this one and this, right? Sorry, 1 0 0 or 1, which will give me 1 0 1. Now what will happen is, since this is a leaf node, this condition will execute sum plus equals, so it will also add 1 0 1 in decimal format, which is 5. So I will be getting in here 9. So this particular subtree will give me 9 in all. Now we also have this to execute. Okay, so let's submit this for now. Okay, yes, thank you.